not the learning of facts. Education is not the learning of facts but the training of mind to think. Hello everyone, myself Nigar Sultana. I welcome you all to RN Digital Learning. Watch this video till the end to know the best sorting technique, bubble sort. Let's understand what is sorting. The process of arranging the elements in ascending or descending order is sorting. There are various sorting techniques like bubble sort, quick sort, merge sort, insertion sort, selection sort, bucket sort, radix sort, etc. Now let's understand what is bubble sort. Now let's move on to our computer screen.
Bubble sort. What is bubble sort? Bubble sort is most popular sorting techniques because it's very simple to understand and implement. Bubble sort is not efficient for the large array. So let's take an example with just n values. We have 5 values in this array. First value is holding 28, then 20, 30, 15 and 5. The array index starts from 0 to 4. Size of an array is 5, that 0 plus 4 plus 1 will make 5. Let's understand this bubble sort with the help of a simple manual example. We need to consider passes here. Like in the first pass, what we will be doing? We will be comparing the adjacent cells. Suppose here we compare the first element and the second element of an array. If the first element is greater than the second element, we must swap. I'll tell you how to swap the elements with the help of a simple example. So first let me understand this bubble sort with a manual calculation. Under pass 1, this is the first round, we will be comparing this 28 and 20. So this is my first element and this is my second element. I'll be comparing. If the first element is greater than the second element, I need to swap. Swap in the sense I need to interchange the values. 20 will goes up and 28 will goes down. In this way. So in the second round, I must compare the second value with the third value. Is 28 greater than 30? Yes. If it's greater than 30, then I must swap. So here in this round, it's not greater than the third element. So no need of swapping. Next, again compare the third element with the fourth element. If the third element is greater than the fourth element, there is a need of swapping. 15 goes up and 30 comes down. Next, compare the fourth element with the fifth element, whether 30 is greater than 5. Yes, it's greater. If it's greater, we need to do the swapping process, that 5 goes up and 30 comes down. So this is our pass 1. What happens at the end of pass 1? Our largest value will be placed at the largest location. That is, in this array, fourth location is our largest place or the largest index. At the end of this pass 1, my first largest element will be placed into the exact correct position. Now let's move for the pass 2. Again repeat the procedure of comparison. Compare the first element with the second element. Is first element is greater than second element? No, it's not greater. There no need of any swapping. Next, come to the next round. Compare second element with the third element. Is second element is greater than third element? Yes. If it's greater than the third element, we need to swap. 15 goes up and 28 comes down. Next, compare the third element with the fourth element. Is 28 greater than 5? Yes. If it is greater, there is a need of swapping. Again, 5 goes up and 28 comes down. So at this end of this pass 2, my second largest element will be placed at the second largest location. That is, 28 will be placed at the third location. Next moves to the pass 3. Apply the same procedure. Comparison of the first element with the second element. 20 is 20 greater than 15? Yes. If it's greater, then swap. 15 goes up and 20 comes down. Yes. 15, 20. Compare the second element with the third element. Is 20 greater than 5? Yes. If it's greater than, then swap. Now at this end of this pass 3, my third largest element will be placed at the second location. Next comes the fourth pass. Compare the first element with the second element. Is 15 greater than 5? Yes. If it's greater than 5, then swap the numbers. Now 5 goes up and 15 comes down. Now this fourth largest element is placed at the first location. See, this is our sorted array with the help of bubble sort. 5, 15, 20, 28 and 30. All the 5 elements are being arranged in ascending order. So we have observed that in the first pass we have done 4 comparisons. In second pass we require 3 comparisons. Third pass it takes 2 comparisons, and at the fourth pass we require only 1 comparison. So this is a result of this bubble sort.
This is the working of bubble sort technique, how we compare the elements to sort in ascending order. Now let's understand this working with the help of function. Watch this video to know the tracing of the elements of an array.
In this bubble sort function, we have used 2 for loops. First for loop is used for passing. That we have pass 1, pass 2, pass 3 and pass 4. To have that pass, we have used one for loop. And another for loop is used for comparison. We have seen so many arrays for comparison. So for that sake, we have used one more for loop, and the if condition we have used. Why do we have used this if condition? We were comparing the adjacent cells. To do that comparisons of adjacent cells, we make use of if condition here. Now let's understand what is this swapping, how it actually takes place. So with this help of the example, we'll understand what is swapping first. So now we have 2 glasses here, A and B. A is containing 30 value and B is containing 50 value. To replace this value or to interchange the value of A with B and B with A, 50 should comes to the A and 30 should goes to the B. Okay, this is a concept of swapping. To do this swapping directly, it's not possible to do swapping. So what we have done, we have taken one more glass named as temp. In the first step, A is holding 30 and B is holding 50. In the second step, what we must do, the value of this A will be kept in 30. That 30 is placed in temp. Now the A glass is empty. When it's empty, then easily I can transfer the value of B in A. So now the value of B is being given to A. In the fourth, now the B glass is empty. I can directly place the value of temp in B glass. See, compare first step with fourth step. My A value we given to B and the B value 50 is being given to A. So this is a simple example of swapping. With the help of one temp variable or the temp glass, we have swapped the 2 variables or the 2 values of A and B. Similarly, this is the code of swapping. We are taking temp variable, and what is the value of A of j? The value will be given to temp, and the next adjacent value, that is j plus 1, the value will be given to A of j. Then whatever there is a value of temp, we will give it to next element. Okay, let's understand with the help of the example. Let's take same example. The 28 is placed at A of 0, 20 is placed at A of 1, 30 A of 2, 15 A of 3, 5 A of 4. Now let's understand from this function. Initially pass value is 1. Next is condition. First I have initialized the value of pass to 1. So this is the initialization. Next is I must check the condition whether pass is lesser than n. What is n? N is the number of data or the elements. N is how much? 5. Is 1 lesser than 5? Yes, it's true. If it is true, I must enter into the loop. I have j is equals to 0. Now there is one more condition. Is 0 is lesser than or equal to n value is what? N value is 5 minus pass. Which pass we are talking about? We are talking about the first pass. Pass value is 1 minus 1. Is 0 lesser than or equal to 5 minus 1 is 3. Is this condition true? Yes. If it is true, now A of j is what? J is holding 0 now. A of 0 is greater than A of j plus 1. J is 0, 0 plus 1 is 1. I must compare these two elements. Whether 28 is greater than 20. A of 0 is holding what? A of 0 is holding 28. Is 28 greater than A of 1 is holding 20. if this if condition is true, then this is the statements of swapping. Already I have told you we will take 3 variables. First, whatever we have in the first will be kept in the temp. Similarly, here also this value 28 will be kept in temp, and whatever we have the second value will be given to the a of j, that is 20. Next, whatever we have kept in temp will be given in the a of j plus 1, that is c. Now, this is the concept of comparisons. We are comparing 28 with 20. If it is true, I must swap. This is a concept of swapping. It has been swapped. 20 goes up and 28 comes down. Now, again I must increment the value of j. Initially, see, this is for increment. J is equals to 1. Again compare 1 is lesser than or equal to 3. Yes, if it is true, I must compare again. A of, now j value is how much? 1. A of 1 is greater than a of j is 1. 1 plus 1 is 2. Compare these values. This is a of 1 and this is a of 2. Compare. Is 28 lesser than 30? It's not true. Then no need of swapping. This statements will not execute in this case. Increment j. J is equals to 2. Is 2 lesser than or equal to 3? Yes. If it is true, check the if condition. A of j is, see, a of j is 2 now. A of 2 greater than a of 3. What is a of 2 here? A of 2 is holding 30. Compare 30 and 15. If it is greater, is 30 greater than 15? Yes. If it is greater, swap. 15 goes up and 30 comes down. Next, j increments. J value will be 3 now. Is 3 lesser than or equal to 3? Yes, it is true. If it is true, I must check the condition. A of j is a of 3 greater than a of 4? A of 3 is holding 30 greater than 5. Yes, if it is true, I must execute this swap statements. This is the end of pass 1. Our largest element will be placed at the largest index. Now, let's see with the pass 2. Now, we must increment j now. J will be equals to 4. Is 4 lesser than or equal to 3? No. This condition fails. Then no need of this j loop now. Stop this j loop, then come out of this loop. Increment pass. Initially the pass value was 1. Now when I increment, the pass value will be 2 now. Pass is equals to 2. Now, is 2 lesser than 5? Yes, it's true. If it is true, enter into the loop. J is equals to 0. Is 0 lesser than or equal to, what is n? N is 5 minus, what is the pass value? 2 minus 1. What is 5 minus 2 minus 1? It is 2. 0 lesser than or equal to 2. That means I must iterate this j loop until 2. If a of j is what? If a of 0 is greater than a of j plus 1, 0 plus 1 is 1. What is a of 0 here? A of 0 is 20. Is 20 greater than 28? No, it is false. Then no need of performing this swap function. Now, increment j. So, j value was initially 0. Now, the j value will be 1. Is 1 lesser than or equal to 2? Yes, if it is true, I must check the condition. A of j is 1 greater than a of 2. Now, I am comparing this a of 1 with a of 2. Is 28 greater than 15? Yes, if it is true, I must swap. 15 goes up and 28 comes down. So, these statements will execute. Next, j increment. Initially So here the j value was 1. Now after incrementing, j value has been 2. Is 2 lesser than or equal to 2? Yes. If it is true, a of 2 greater than a of 3. What is a of 2 here? 28. Is 28 greater than 5? Yes. If it is true, I must execute the statements, that is swapping. 5 goes up, 28 comes down. Now I must increment j again. The j value will be 3. Is 3 lesser than or equal to 2? It is false. When it is false, come out of the j for loop. Now I must increment the pass. At the end of this pass, the second largest element is placed at the second largest index. Now when I want to increment the pass, initially the pass value was 2. Now the pass value will be 3. Pass is equals to 3. Is 3 lesser than 5? Yes. If it is true, enter into the loop. J is equals to 0. Is 0 lesser than or equal to, n value is how much? N value is 5 minus pass is 3 minus 1. Is 0 lesser than or equal to 5 minus 3 is 2, 2 minus 1 is 1. It's true. When it is true, enter into the loop. A of j. J is how much? J is 0. Greater than j plus 1 is 1. I must compare a of 0 with a of 1. A of 0 is holding 20 and 15. This is 20 and a of 1 is 15. Compare. Yeah, it is greater. If it is greater, then I must execute this swapping. Now 20 comes down, 15 goes up. Yes. Now increment the value of j. J is equals to 1. Now is 1 lesser than or equal to 1? Yes. If it is true, start comparisons. A of 1, a of j is 1. Now is greater than a of j plus 1, that is 1 plus 1 is 2. What is a of 1? A of 1 is 20. Is 20 greater than 5? Yes, it's true. If it is true, execute the swapping. What happens? 5 goes up and 20 comes down. Increment j. Is j is equals to 2. 2 is lesser than or equals to 1? It is false. Then come out of the loop. Increment the pass. Pass value was 3. Now it is 4. At the end of this pass, my third largest value will be placed in the third largest index, that is second. Now 20 is placed at the second index. Pass value is 4. Is 4 lesser than 5? It's true. If it is true, enter into the loop. J is equals to 0. Now compare. Is 0 lesser than or equal to, n value is 5 minus pass value is 4 minus 1. What is this? 0 lesser than or equals to 0. It's true. If it is true, enter into the loop. A of j, j is 0. Compare a of 0 with a of 0 plus 1, that is 1. What is a of 0? 15. Is 15 greater than 5? Yes. If it is true, do the swapping process. 5 goes up, 15 comes down. Yes. Next, after doing this swapping, increment the value of j. Now the j value is 1. Is 1 lesser than or equal to 0? It's false. Come out of the loop and increment the value of pass. Pass is equals to 5. Again do the comparisons. Is 5 lesser than 5? It is false. Then stop this for loop also. Now at the end of this pass 4, our largest fourth value is placed at the largest fourth index, that is first. Now all the passes have been completed. All the elements are being arranged in ascending order: 5, 15, 20, 28 and 30. So this is a function of sorted array. All the elements have been arranged in ascending order.
Like the video, share the video with your friends, and do not forget to subscribe our channel. Stay tuned for the next video of next sorting technique. Thank you.